Essentially, we're trying to figure out what the customer's pain points are.
Okay.
Sometimes they do know what their pain points are, whether that's cavitation with their pumps aren't lasting as long as they want them to, but there are other issues that they might not be aware of. Air is known to be the silent killer.
Okay, welcome to another edition of HYDAC On Tap, where we dive into today's issues facing OEM and machine manufacturers in the industrial and the mobile markets. We like to tap into the HYDAC expertise. We have over 60 years of experience. And today I'm joined by two of our experts. Could you introduce yourselves a little bit, gentlemen? I mean, we've got two fresh-faced young engineers here, so it's nice to see you gents.
Yeah.
Tell me a little bit about yourself.
Yeah, my name is Derek Schwab. I am the lead development and simulation engineer here at HYDAC. Been working with the H&L group, hydraulic and lube group, for 6 years. And my position, I do simulation-driven product development. That includes CFD and FEA. So
what is CFD?
CFD is called Computational Fluid Dynamics. It's a physics-based fluid dynamic software where I can simulate the fluid behavior inside hydraulic reservoirs. And then FEA is finite element analysis, which I look at the structural, which I look at the structural components of the filter products.
Nice. Okay. Well, welcome. Glad to have you here today. And Bilal, can you tell us about yourself? Introduce yourself.
Yes, sir. Bilal Muhammad, product manager for the H&L Filtration Group. Been with HYDAC for about 3.5 years. I mainly work with the mobile OEM customers. Yeah, thanks for having us today.
Oh, I'm glad you were able to join us. So let's dive right into it. What are some of the key issues facing the hydraulic industry? Most specifically, probably filtration, since you guys are in that niche area. What are the issues facing the mobile and industrial markets today?
Yeah. So we've always known that dirt, debris can really damage a hydraulic system. But after some research and some findings, air is known to be the silent killer. And so we at HYDAC have determined that we wanted to figure out technology that's able to not just filter debris, but also filter out air as well. And so we wanted to come on today and discuss how we do that.
And so, as I understand it, it's called filter deaeration. Can you explain that topic a little bit more?
Yeah.
Yeah, just to start off, that the type of issues that we find in hydraulic systems or that could happen is we have varnish, which that's the sticky residue that's created inside the hydraulic reservoir due to oxidation. And then cavitation, you'll have air bubbles damage different components by the bubbles moving towards the metallic components and causing micro, fractures. And then we have micro dieseling effects, which is actually the bubble explodes at a metal surface and causes pitting. And as far as filter deaeration analysis is a process that we do at HYDAC. So we look at the customer's baseline tank, which could have a variety of issues, or maybe their tank is actually very large, so they could have a very high velocity jetting into the tank. They could have oil and air, or oil splashing out the breather, leakages. They could be placing the return fluid or return pipe right next to the suction, having a direct connection to air to get entrained into the system.
Essentially, we're trying to figure out what the customer's pain points are.
Okay.
Sometimes they do know what their pain points are, whether that's cavitation with their pumps aren't lasting as long as they want them to, but there are other issues that they might not be aware of, like air in their system.
Okay, so why is if air is so bad in a system, why does it exist at all? And how do you determine that it's an issue with your customers?
So we could determine that it's an issue based on, one, their pumps. If they're telling us that their pumps are cavitating after a year or two, that's not supposed to happen. And so we know right away there's air in your system. And so we can then show that via Derek's work, which is the CFD. And so through the CFD, we can show them that if their air is in your system, it's probably going to stay in your system based on your filter tank design. So we actually have an air content sensor that can either be taken to the customer's facility, or they can bring their machine to our facility in Chicago, where we can actually hook the machine up to this air content sensor. And what we'll do is we'll basically validate Derek's work by hooking up the air content sensor to the machine with the baseline filter tank system and go through a couple different functions, whether it's raising, digging, whatever, and see how much air is actually found in the system. Once we get that data, we'll then swap out the baseline filter tank system with the HYDAC optimized filter tank system, which includes the AirX filter, and then compare it to that data and basically see how much air is in the system using the optimized version.
Okay.
And so you get a side-by-side comparison, basically validate Derek's work showing that the optimized version has less air.
And you show that through like a visual of some sort or some kind of demonstration of what the difference and what the savings will be?
Yep. So typically we pull in the data from the air content sensor and we'll look at it and see that there's a percentage of air inside the tank. So we could say that baseline maybe has 3% air and we want to reduce that to 1% or better. And so the optimized tank with the AirX filter will, our goal is to have that 1% or better, which will indicate that there's a clean oil system.
And a lot of the time, it will answer questions that the customers had for years. Why is our pump cavitating as often as it does? And so this basically gives them that answer. Well, based on our air content sensor, you have X percentage amount of air in your system. And like Derek said, we go from a large reservoir with a standard filter and then being able to optimize it by using HYDAC's AirX, which I think this is the first time we're mentioning what the magic is behind this whole process.
So tell me about this AirX magic or this AirX technology. Tell me a little bit more about that.
Yeah, so it's the reason why we're able to do what we do and what differentiates it different than a normal return filter. And so I actually have a couple showpieces that I could
please
up.
do.
Yeah.
Show and tell. I love it.
Of course. So this is actually one of our AirX filters.
Okay.
This is specifically our RFB compact. RFB is return from bottom. So the oil will actually enter the filter from the bottom and exit from the sides. And so this is called an in-to-out filter. All our AirX filters are considered in-to-out. And so what that means is the oil will enter the filter from the inside and then exit from the outside. And so because of that, that's how we're able to do such massive reductions. When the oil is entering at a higher velocity and then exiting at a lower velocity, the oil doesn't need that extra time and space in the reservoir to deaerate. We're confident the oil can basically exit the filter and go straight down to the suction port. With your standard return filter, that's not the case. Usually the oil is jetting out of the filter outlet, and so the reservoir needs to be oversized to give the oil time and space to deaerate prior to going down the suction line. Because if it does go straight from the filter to that suction port, then that oil is probably going to be filled with air. And like we said earlier, that air is probably going to damage the pump. And
so the standard way is actually creating air with that jetting of the liquid.
Correct. You can actually see that oil jetting out of the filter into the tank, and you can see all that sloshing and disturbance occurring where all those air bubbles are being formed. And because of that, that's now why the reservoir has to be oversized the way it is, because it needs that extra time and space to deaerate prior to going down the suction port. And then on the left-handed side, you can see a much smaller reservoir where we've actually utilized this filter here, which is our RFT compact. And you can see that you'll have to look fairly close to that visual, but the system's actually running. And you can barely see the oil exiting the filter into the tank, but it is running. and it's actually running at the same exact flow rate. But just because of the AirX technology, it doesn't cause that sloshing and disturbance, which is why we're confident the oil can pretty much exit the filter into the tank and go right to the suction port, air free.
So bringing back this filter, as we discussed, I mean, we have the oil that will enter through the return port and then into the interior portion of the element, and then circulate and exit out of the element 360 degrees. So you'll have very, very low velocities. And if any air is coming in, that's going to cross the element and then the coalescence screen and allow the bubbles to coalesce, group together and form larger bubbles. And because of this low velocity and larger bubbles performance, you're going to see bubbles coming out and rise to the surface and deaerate right away, while any other smaller bubbles that exit will continue coalescing, and then you'll have very, very clear oil compared to a murky, oil that contains a lot of aeration inside.
So you're talking about dirty oil?
Yeah, dirty oil.
Okay.
Well, murky oil from the
murky
aeration.
oil. Okay.
Yeah.
That's the official term, murky oil.
Yeah.
Okay. I call it dirty oil, but okay. What do I know?
Yeah. We could go to the customer site and we'll put this device on, the suction hose or anywhere in the tank where we want to see and record air, and we'll be able to physically record the air content inside the tank over a certain amount of time, and it could be 10 minutes, 20 minutes, and that could be during any type of function of the machine, which is, if the machine's digging, lifting, raising dirt, or telescoping, all of its cylinder movements.
Essentially, what we want to do is validate Derek's work. Some customers may be skeptical about the CFD, and they're hesitant in making such major reductions. And so we offer this air content sensor as a tool to validate Derek's work. So what we do is we take their baseline machine, and like Derek said, we'll go through a couple different functions and show them that with your current filter tank system, we've read this amount of air in your system, basically validating what Derek found. And then we'll swap out the optimized filter tank system, the baseline filter tank system, and install the HYDAC optimized filter tank system, incorporating the AirX filter, and basically see the difference in air content.
And so then how do you demonstrate that value between the two systems?
It's basically in a graph through a percentage. And so you'll see whether it's 1%, 2% air in the baseline, and then less than 0.5% for the optimized filter tank system.
Excellent. So you mentioned, I don't know which one of you mentioned this, but you talked a little bit about reducing the size of the tank,
Correct.
reducing the amount of oil. So there's probably some sustainable messages here too.
Of course.
Can you talk a little bit about that? Like what kind of other benefits are the customers getting just besides the better system efficiencies?
You can imagine that there's a major cost reduction when you're going from a 20-gallon tank to a 10-gallon tank. You're basically cutting the tank material in half, but then you're also cutting that oil in half or 30%. So reducing that oil volume, that's obviously a huge cost savings. Oil nowadays is $10, $15 a gallon. So being able to reduce that from the cost of the machine is obviously a win for the customer, but it's also a win environmentally. Sustainable solution, that's all that everyone's really talking about nowadays, zero emissions, and so that's how you get to that point.
What about maintenance issues? You mentioned less pitting and some other things, so you probably get some cost reductions there as well.
Of course. And so yeah, like Derek was saying, with the varnish of the oil, maybe they're replacing their oil every year, but now that the oil isn't getting as dirty and there's less varnish being accumulated, they're replacing the oil every 2, maybe every 3 years. So that's a huge cost savings there.
Can you guys give some examples, some real-world examples of where we've used this technology for unique solutions for the HYDAC customer?
Yeah, so we mainly work with, I think, 2 industries, the mobile industry and industrial. And for mobile equipment, you can imagine you have tractors, you got wheel loaders, you got agricultural machines, you got anything very large tractors and mining trucks, and then you got very small machines like a little snowblower, and you could have like a grass cutter, forklifts.
Yeah.
And then for the industrial side, we have offshore oil and gas turbines, wind turbines, and anything in the factory like a paper mill. So, and one of the interesting projects that I've worked on is the snowblower. We were able to reduce the tank, very large amounts. I think it was over 50%. And then now they have a very small 1 gallon tank. And this actually reduced the weight enough to increase the battery life significantly. So when someone's using this machine on, to push the snow out of the sidewalks or roads, they will be able to last longer in that area.
So you're talking like an industrial snowblower, like a large piece of equipment.
Yeah. So a single-seated snowblower, it's manned vehicles, and they could just ride around. You could purchase this for your house.
Oh, okay.
So mass-produced.
So even on a simple machine like that, this kind of technology will have those same benefits.
Yeah.
Of course. Because nowadays,
Absolutely.
mobile manufacturers want to make their machines faster, stronger, but then they also want to make it smaller.
Okay.
And so when they have a large reservoir, they don't know what to do with it. They don't know where to put it. They don't know how to fit the reservoir with all their other high-tech components. And so going through this process, they might have allotted 10 gallons of space for the tank, but they need a 20-gallon reservoir, and they don't know how to make it work. Well, going through this process would help them out. We could even reduce it potentially down to 5 gallons, and now they have more space than they would have liked.
And I would say another added benefit is that it takes a lot of work to assemble a hydraulic reservoir. You got welding, you got to put a baffle in, and you got to make sure it's clean inside when it comes to the manufacturer. So the benefit is, we eliminate the baffle, because baffles can actually cause additional sloshing and aeration inside the tank because of the high velocities that cross over it. And by doing that, you eliminate the baffle, and then the end user can receive the hydraulic machine faster, because we're reducing the time and man hours required to put the tank together.
Let's talk a little bit more about cost reduction, because you brought that up earlier. What are we talking about? Are we talking about significant percentages in cost reduction, or, can you unpack that a little bit?
Yeah. So obviously a big part of that is how much they actually want to reduce the system. A lot of customers may be hesitant in making such a major reduction, but the customers that have been willing to make that reduction because they believe in the technology, we've seen maybe 60% reduction in volume. And if they're making, let's say, 500 or 1,000 machines a year, we can see upwards of $150,000 savings per year. So,
for one particular manufacturer.
Exactly. And so
that's pretty significant.
Yeah. So a lot of customers, when they see that value, they can't wait to get the process started.
So you mentioned some kind of form that they fill out, and how do they start this process? They reach out to you, Derek, or you, Bilal. How do they start, investigating how they can, benefit their machines through deaeration, through smaller tank size, and then eventually, lower their overall cost?
I'll get connected to them, and I'll basically pitch the idea to them. And most of the time, when I say, this is what the process is, and it's free of charge.
Right.
Oh, they can't wait to fill out that data sheet. Yeah. And they'll get it back to me the same day. And at that point, I'll then pass it off to Derek, and then he'll do his work for 2-3 weeks.
The system analysis.
Exactly. And then we'll present the results to them. This is how your baseline filter tank system performed. And then we incorporated our AirX technology, reduced the tank by 30%, and then this is how it performed. And usually we're seeing an improvement in performance and then also that cost reduction. So at that point, it's just all advantages. So it's kind of, you really don't know why the customer would say no to this solution.
Right.
It's a win-win for everyone.
Yeah. So where do you guys see the future of the industry going? You talk about regulations and those kinds of things. Do you see more of that? And are we able to meet those changes in the industry?
I would say, yeah, we in the future we're probably going to see more filter deaeration analysis being performed on customers' machines because, especially metal tanks and increasing in prices, we actually offer a rotomolded tank, so from our sister company Schroeder, and that'll reduce the overall cost of the hydraulic package, and we can sell it as a complete solution for the customer, which would include the filter, breather, the rotomolded tank, the sight gauge, strainer, whatever they need on their system to function well.
So it's not just the AirX technology. It's not just the AirX element in the filter. It is, the breathers, the tank size, it's the rotomodal, non-metallic tank.
Yeah.
It's everything. So
Exactly.
that's the whole systems approach. So that's
Yep.
excellent. Well, let me ask you this. So what are the competitors doing? Are they doing something similar? Are they doing deaeration? So, how does this set us apart? Because I think this is pretty unique.
So
Sure.
some of our competitors do have in-to-out filters similar to the AirX, but when we've conducted testing internally, we've seen that they might not work as well as the AirX technology without getting too in-depth. Our other competitors are where we have the AirX being done by the filter, other competitors are doing it with the tank. So when the tank manufacturer is offering a tank that's doing the deaeration, that kind of pigeonholes the customer into going with that super custom, super unique tank. Whereas our AirX filter, that's what's doing the work. And so you're able to incorporate that in a standard reservoir.
So that can go in any kind of tank.
Exactly.
Any size tank. Certainly
Exactly.
to your earlier point, we do the whole system, the whole package. So we do downsize the tank. We do offer the AirX filter. We do offer breathers that are working in concert as a total package. But,
Exactly.
But basically the AirX technology will work in any tank.
Yep.
So you don't, like you said, you're not pigeonholed into using a unique solution based upon the tank.
Yep.
Okay, that's excellent.
So some other examples that our competitors are doing or selling or customers are purchasing are you have the Cyclone tank, which it operates with principles of a cyclone, and this will the function of it is to separate the air from the oil. Doesn't include a filtration component to clean the oil, and this pretty much it allows the bubbles to rise to the surface that are, of a certain size, but the very small bubbles will stay in the system. You'll need a constant flow rate for this to work correctly to stabilize the vortex, and so it's very custom and expensive device compared to our AirX filter. I mean, you can have any velocity into the tank, and it'll deaerate and remove the air inside the hydraulic reservoir. And then the next one, I think it's called hydronucleation.
Sounds complex.
Yep, very, very complex. Yep. And this one, based on my research, it looks like a hydraulic reservoir, very custom reservoir that has a diffuser with an element in it. And that also has an anti-splash baffle. So with all this complexity, I mean, you can imagine that you need a custom-sized tank, and that's going to limit to the customer for that size tank. While again, AirX will utilize any size tank, as well as we will size for the customers sloshing and splashing to ensure that there's no leakages coming outside of the reservoir tank.
So it sounds like you guys have done your research and found a unique solution that we can offer our customers. So anything else you want to add today?
I wanted to say that, the hydraulic system, it might be, the last thing you guys are thinking about, but it's a very important part of the system. We want to reduce any type of issues inside your tank, and we can offer the AirX filter. We will work closely with you guys running a CFD analysis on the system, look at the deaeration velocities, ensure that your tank is sized up correctly for your future use of it.
All right, and one more time, CFD is?
Computational Fluid Dynamics.
Okay, I'll try to remember that.
And one more thing to go off of what Derek just said. To get the most out of going through this process that Derek just mentioned, the filter duration analysis, is to make sure that we're really a part of that initial design phase. A lot of the times we'll get the filtered data sheet filled out, but at that point we're pigeonholed into a certain design or a certain space claim. And so
if you get in earlier in the process,
Exactly.
you can help find that unique solution for them.
Exactly. We're not really able, our hands are tied when it comes to the amount of reduction or the reservoir shape or size. And so, but if we're involved from the beginning, then it's basically a blank page, and we're able to optimize a tank that can be optimized in any way. So just fill out that filter deaeration data sheet as soon as possible. As soon as you know that you're going to redesign a machine, get HYDAC involved.
Excellent. So how do you show HYDAC customers these cost savings?
Yeah, so I would say the last step of Derek's CFD presentation is then showing a value hypothesis, which you can now see on the screen. It basically compares the costs side by side. Cost A would be the baseline filter tank system, and you can see that there's the filter cost, the tank cost, the oil cost, and then a total cost down at the bottom. And then if you look at scenario B, that's the HYDAC optimized solution. And same thing, filter cost, tank cost, oil cost. If you look at the full picture and not just filter costs side by side, you can see that there's actually a major cost reduction when comparing the tank sizes, the oil volumes, etc. You can see that in this example, it's $150 in cost savings per machine. And in this example, it's 1,000 machines per year. So then you can get your annual cost savings. And so breaking it down for the customer where they can actually see all the different costs that are going into this whole optimization, that's when they really see the true cost savings. If I were not to share this information and just compare it filter cost to filter cost, they might not want to go down this route. But you also wouldn't be comparing apples to apples because the AirX filter is incorporated in a much smaller tank with less oil. So there's a huge cost savings there.
So you got to look at the big picture and the whole program. And
Exactly.
is this typical? What that example you just showed, is that a typical kind of value analysis? That's the kind of savings we're talking about on a regular basis?
Yeah, and I would say I'm being pretty conservative.
Well, thanks, gents. Appreciate you coming out and taking the time out of your busy day to share this with us. For all you, our listeners, certainly reach out to Bilal or to Derek or go to your local HYDAC salesperson to start this process. But most of all, like and subscribe this channel. We will send you alerts. You can follow us on YouTube or on your favorite podcast program streaming service. Again, thank you again for coming out today, and we'll see you on the next edition of HYDAC On Tap.
Thanks for having us.
Thank you.